and it's connecting. There we go. Super excited to be hosting the session today, Token versus Session Authentication with Sarah Levins. So if you can join me in giving Sarah a nice big warm welcome, and we'll crack on with tonight's webinar. Over to you, Sarah.
Hello, everyone. Thanks for having me, Kate. So patience with me tonight will be appreciated. I'm a Teams and a Google Meets girly, and I just had to download Zoom, so we'll see how well I go. I'm sure it's all the same. I'm sure it's fine. It can't be that hard. We're in tech. It's fine. Anyway, tonight, Kate and Ollie reached out to me and asked if I could give a session on authentication, specifically token versus session, what they mean, what the differences are, just to give you a bit of context around what you'll be building this week and in the coming weeks with your REST framework backend, and then moving forward into the rest of the Plus course with your full stack application, bringing it all together. So let's dive right in. Who am I? Kate just introduced me, but I am a She Codes Plus mentor in Perth. So anyone who's on the call from Perth, you may have met me. If not, you'll see me around the streets. Perth is really small. I'm also a She Codes Plus alumni. So I did the course in 2019, which is apparently 5 years ago now. But I can still remember all the content like it was yesterday. And now these days, I'm a software engineer at Microsoft. So I work on their video editing platform called Clipchamp. If you haven't used it, you should. And I get to show you a bit of it later in this talk. Just for, I guess for context around who I am, I basically started where a lot of you are at the moment. And everything I'm talking about today, I've learned through the course, the She Codes Plus course, or through the first 4 years of my career as a software developer. So this is the kind of information that I think is going to be really useful to you as junior developers or people moving into more technical roles or technical facing roles in tech, knowing how authentication works, the colloquialisms and the jargon around it will be really handy, not only in building things, but also maintaining and talking about things and working with others on applications. So pretty much the reason we're here is that authentication is key to pretty much every application and website you can think of, bar a few unauthenticated ones. And it's just really important to be aware that there are options and different types of authentication in play. And it's a really good skill to have as someone in tech, to be opinionated about when it comes to what kind of implementation of authentication the application you're working on should have. There are a lot of established protocols and flows when it comes to auth that have been set out and security reviewed by governing bodies. So you don't have to reinvent the wheel when it comes to auth. You just have to understand what's out there, the pros and cons to each, so that you can pick the one that's right for you. So what we're going to learn today, and what I hope that you can walk away with, is just basically a base understanding of a few key concepts. So we'll cover a few methods of authentication. And so for you in the Plus course, we'll be looking at session and token, which tie directly to what you're going to be doing this week and next week. And then I'm going to go, depending on time, a bit above and beyond that into more industry standard authentication protocols and what that looks like in a real world scenario. Some of the code you will see is going to be the crowdfunding backend that you are working on as part of the course. Do not feel the need to code along, try to write down anything as I'm going, pausing the video, rewatching this later to copy the code. It's everything you see on the screen will be what is in the content and what you'll go through in class and what you'll build as part of your project. So just listen and learn. The biggest takeaway I think that you can get from this is a mental model of about how authentication works, not just in what you're building, but also in day-to-day flows. And building that mental model will help you be able to build authentication flows of your own and debug scenarios when they're not working exactly right. So before we dive too deep into things, I just want to make sure that we understand the basics. So in layman's terms, authentication is the process of verifying who someone is and what they're allowed to do. So it's like checking someone's ID to make sure they are who they claim to be. When a user authenticates on the website, they provide something about who they are. So it might be username and password, or some kind of like multi-factor authentication thing or something like that. But in simple terms, we're just going to be saying username and password at the beginning of this talk. So a very basic example is, let's say you go to a website, you put in that username and password and you log in, you're starting the process of authentication. Your details get sent to a backend server and it verifies if they're correct. If they are, the server will send back proof of verification in the form of some kind of data, and the different kinds of data we're going to get into in this talk. The client stores that proof of authentication in the browser or application so that it can be sent along with every subsequent request to the server. So if you have an authenticated front end, if you make a subsequent request to the server, it then checks that little bit of data that you sent with it. It says, cool, yep, that's you, Sarah. Here's your data back. In like a real world scenario, let's say you went onto everyone's favorite video editor website, Clipchamp, and you logged in, and the application needed to find out what video editing projects you had. The front end would send a request to the server with a little bit of data that says, Sarah's logged in, she needs to know what her projects are, please. The server would receive that request, verify that bit of data that was sent with the request, say, yep, that's Sarah, I believe that's Sarah, and it would send back all my video editing projects. Same thing would be like, if you went on Facebook, you logged into Facebook. I don't know who does that these days. You logged into Facebook, your login details would get sent to the back end. The data that would be returned would be things like your posts specific to you, or your friends' specific birthdays, and things like that. So how the back end server handles checking that proof of authentication, that little bit of data that you send, it can impact security and performance of your application. So that's kind of what we're going to focus on in terms of like the trade-offs between the different types of authentication, how that backend server handles checking the kind of proof that you send about who you are. So generally speaking, this can be done in two different ways, statefully and statelessly. So we'll start off with statefully. When an application handles authentication in a stateful way, it keeps a track of a user's current authentication status, usually in a database. So when requests are made with proof of authentication, the backend verifies this and then checks a state table in a database to see if that user is currently logged in. If the data sent with the request matches the data of the current logged in details, the server's like, yep, that's cool, and it sends the data back. Alternatively, when an application handles auth in a stateless way, the backend doesn't track the current state of the user's authentication status. There are enough details in that bit of data that's being sent with every request to verify that the user is who they say they are. So the backend server doesn't need to constantly check a session table or update the session table with updated session status, essentially. So understanding the difference between stateful and stateless auth is, like I said, key to being able to determine which one is right for your application. Stateful auth tends to be more secure because it's very hard to infiltrate and steal kind of the state data out of the database or kind of fake that. That being said, it is clunkier and slower because you have to make repeated requests to a database to read and write data. Alternatively, stateless auth is faster and cheaper because you're not reading and writing to a database a lot, but it comes with a loss of visibility about how many users are logged into your application and what their sessions are. And it does raise more discussions about how to keep things secure. So we're going to move into some more of those concrete authentication methods now, like session and token. But before we do, does anyone have any questions about any of those concepts? No, I see Kate's got a cat that might have a question. Its tail is risen. I've locked mine out of the room. He would be too rowdy. Great, well then we'll move on. So just like you've been using established coding frameworks like Django and React to make coding your applications quicker. We haven't started using React yet, but don't worry, it's going to make it quicker. There are established practices when it comes to authentication that you can adopt in the way you build out authentication in your apps to make authentication easier. like I said earlier, there's no point like reinventing the wheel when it comes to these things. So authentication methods are concrete protocols that the applications follow to authenticate users. So the list I've got here, you've got like biometric authentication. So if you've got a laptop with like a fingerprint scanner, that's kind of like biometric authentication. If you work for a company that has single sign-on, you might have a username and password that you enter, and then that will log you into every program that you need for work. A lot of those come with multi-factor or two-factor authentications where you have to accept a notification on your phone. And there's more complex types, such as like certificate, and we won't even touch that today. All we're going to focus on today are session and token auth, which mainly deal with web applications and mobile applications and those kind of client-server relationship applications. So we'll start with session auth. So in essence, session authentication is where the backend server stores data about the user's authentication status in a database. And so it's stateful. And another defining factor of it is that it returns to the client that data about proof of authentication in the form of a cookie that is then used in all subsequent requests. So this diagram here, which if you're not zoomed in, is very hard to read, but don't worry, we're going to zoom in for you, goes through the entire flow of how this works. In layman's terms, session auth is kind of like the equivalent of walking up to an exclusive and saying to the bouncer looks at the list, and if they can find you, they let you in. So the bouncer is, the clubhouse, the bouncer is the server, and the list is the database, and you are the person walking up to the clubhouse. So the bouncer, the server, needs to go to the database and check that you're in there, and if you are, they'll let you in, and by letting you in, they mean give you a cookie or return the data that that you've gone to the backend server or the clubhouse for. Really powerful analogy. I love it. So let's go through the flow of it. You're a user on the right there, the top right. The user provides credentials. So the credentials are provided to the backend server. Those credentials are then matched to the server queries database, to see if those credentials match a user. And if they do, a new row is inserted into another table in the database, which is a session table. The server then gets the information from this session, so it'd be in the form of an ID, and then the server returns a cookie to the user. And a cookie will contain a session ID, and that's stored in the browser. Then with every subsequent request, the user will make requests from the browser, including that cookie. The server will then go to the database table for the sessions and check if the value in the cookie matches the value of the session in the table. If it does, you're good to go, and it will continue and get the rest of the data and return the data requested back to the user. So I mentioned the use of cookies there, and it is one of the key features of session auth. And I'm sure you've heard of cookies in all those banners that pop up on every single website asking you to give consent for websites to use it. But I thought I'd just kind of break down exactly what they are in case you haven't looked too much into them and you just click yes, like I do all the time. So cookies are basically small pieces of data that the websites store on your browser. So they help websites remember information about you between visits. So if you leave the page and come back, or if you navigate through to different pages in the site or even subdomains of the page. The cookie is like a bit of data that is stored in the browser that will persist and can be used and picked up at any time. And additionally, cookies then allow requests to the backend the browser then attaches cookies to any request that is sent to the backend of that domain automatically. So if you're on a website which has a cookie on it, any request that you make to the backend from that front end will include the data on that cookie. You don't, as a developer, you don't have to worry about picking it up and including it as you would have to do in some other methods. So I want to kind of go into more of a concrete example of how that will work, just so you have an understanding of where to look for these features as you're developing it. And like I said, we're going to do it in the context of the crowdfunding API that you're building. So I've got my version of it here, and I've got my virtual environment activated. Just checking before I go guns blazing. Can everyone see VS Code at the moment? Cool, beautiful. All right, so I'm going to start it here. And we're up and running. So if I go to localhost 8000, let's go to users. As you can see, I've got the Django REST framework UI open here. If you're in Perth, I don't believe on Tuesday we made the user endpoints, but you'll be doing this on Saturday, and soon you'll be able to create and update users in your application, which is fantastic. So don't worry too much about the fact that this exists at the moment. This will happen shortly. But just focus on, I guess, the structure of the Django site. So here I can log in as a user and I'll be able to make requests accordingly. If I right click on this page and inspect, I open up DevTools, which basically gives insights into what is being stored on the browser and the requests that the browser makes. So to view what cookies are stored on the browser, I can come over to this application tab on the top right, and then down in storage, there's another tab that says cookies. And here I can see my domain, which is currently localhost. I have one cookie stored, and it's called CSRF token. I might just zoom in slightly. It's called CSRF token, and it's got a value which is just like a random string. So this token here is, this cookie, which contains a token, is placed on the browser by Django automatically whenever you load the page. So if I go to network and I look at all, I'll just refresh the page. I've loaded the page, and this is the page that's been loaded. I can see when I've made a request for this page, it's come back, oops. The response that has come back for this page has told the browser to set a cookie CSRF token with that value. So don't worry about it too much. For context, CSRF stands for cross-site referrer forgery, which is a kind of attack that malicious actors can do on your site. So basically they can create kind of like a fake page and have it talk to your backend to trick users into entering their passwords, username and passwords into their site. This token prevents that, or like fights against that. So that's the purpose of that token. The important part is that our request to the backend, localhost 8000, has asked the browser to set this cookie on the browser, and it has to an account which I created previously with my super secure username of Sarah and my super secure password, which is also Sarah. Don't tell anyone. If I log in and it has, yes, I know my password is not safe. It has a unique value here of another kind of unique string. That is, if we go back to what we were looking at in our flow, that is the ID of a session that has been created in a row in a table. The browser has then sent back a cookie that is now saved in the browser. Oh, sorry, the server has sent back a cookie that is now saved in the browser, and that is the cookie that is saved in the browser. If we have a look at our database here, we have some tables. I've got users, custom user. I've got one user with an ID of 1, and that is me, Sarah. And we have another table here called Django session. You can see here I've got a couple of sessions here. This one here, JWFVTUH, that matches the session ID I've got here. So that is the session ID that when I send a request back to the backend will be checked against in order to confirm whether or not I complete the flow. The session table holds the cookie value as a session key, and then we've got session data, which is an encrypted form of the user information that it's related to. So in here, you would decode that, and that would say, okay, this is actually Sarah's session ID. If I made a subsequent request with the backend, so let's say we went to projects and we wanted to create a project, I'll create a new unique project, not called project 3 or project 4. I'm going to call it project 5. Now, if I make this request in our network tab, I should see the request go through to the back end. And here we got a request made to localhost 8000/projects. It was a post request, and the response was 201 created. So a project was created. If I scroll down, I can see in the request headers, so in the data sent with the request, it included the cookie, session ID. So like you were saying over here, I've sent the request with the cookie, and it was automatically added to the request because it sits on the browser under this domain. If I was to delete that cookie, so if I come back to application and I just click delete and it's gone, if I then tried to make another project 16 for some reason, someone just opened and closed my door, and I tried to make it, I would get a 403 forbidden. So my authentication credentials weren't provided. There was no cookie. There was no session ID cookie sent with the request. So there was a cookie present. It was the CSRF token, but the session cookie wasn't there because I deleted it. So that's kind of like how you would go through and inspect what exactly is happening in the browser with session authentication. So being stateful, like I said, it's quite secure, session authentication, especially with preventing cross-site request forgery attacks. It's also really the preferred authentication method, I would say, for full stack applications when they're hosted on the same domain. So traditionally, Django applications, the framework itself allows you to build out a front end on the same domain or the same served from the same place as the backend. And that tight coupling means that requests from the front end to the back end are really secure because of the use of cookies and so on and so forth. That being said, it doesn't really work when you want to use a dynamic front-end framework like React, where requests will be made from a different domain because it's a different application you have to deploy to a different place. And it's also not great for clients where the browser is like the front end isn't browser based. So like mobiles and like different IoT devices and so on and so forth. So if you want your API to be callable from several different kind of forms of things, it's not really scalable. It's very much browser based. And like I said, because you're making so many requests from the server to a database and back, it's not good for high volume. If you had 500,000 users on your website at any given point in time, you'll be making millions of requests and writes and reads to a database, which would slow everything down and it will cause you a tiny fortune in costs. So that's why we have alternatives such as tokens. So an alternative would be, like I said, a token. When we come to talk about the piece of data that you would send to the server to prove who you are. Tokens are effectively like a string value that has been encrypted in a certain way. So the backend server is able to verify that tokens are real by looking at whether or not the way that token has been, or the way that string has been encrypted is valid. So a good way to think of them and why we've used this with Logo is to think of them like keys, and think of your backend server like a door. So if you've got a door, you could have 3 or 4 different keys that would be able to open that door. You would also potentially have other keys that look identical to those keys, but they won't work on that door because they're not cut in the right way. And the only way to cut a key for that door is to kind of know how the key should look and work, and potentially be the person that made the lock for that door. So when you make your backend, which is the door, you basically design a way to encrypt your tokens, and you keep that a secret. Then when people send the tokens that you give out back to you, only you know how you're supposed to decrypt them in order to check if they're valid. So I can run through a quick example of what you'll be doing in the crowdfunding app and what it will look like to use token authentication instead of session authentication in a Django project. So I'm going to stop this one. Get that out of here. Bring, oops, this one over here. All right, so if we pop back to Django over here, straight off the bat, you can see that we've lost the login button. So because we've switched from session auth to token auth, Django knows that, okay, I'm not able to directly talk with the session thing. I'm not going to enable any kind of interaction via the browser because we're going to need a different type of authentication that this front-end client isn't really equipped to do. So we're going to have to do all requests to the backend now that we're on session auth, now that we're on token auth through Insomnia. I've got Insomnia up here. Just clear that out. So if I am let's say I'm going to create a user. So I'm going to localhost, which is 127.0.0.1 users. Let's create a user called username and password. And this is my user. Their username is username and their password is password and the email is email. So secure. Let me then log in to the back end with those details. Is that I forget what it was. It was like 2 minutes ago. There we go. Now, when I hit this token auth endpoint that we create as part of the work we do, instead of the browser returning a cookie and us storing that, we manually make a request to a new endpoint in our backend, and we're returned a token, which is here, as you can see, an encoded string. If I was to try and make a project, so we'll come back to create a project, which is /projects post. Let's call this project 45 for some reason. If I was then to try an authentication failure because I haven't provided any authentication, because we've switched the backend to use token auth, I need to provide the token auth through the auth tab or as an auth header. So in Insomnia, I'd click the auth tab. I make sure I choose bearer token. I would place the token that I received from my initial login request and prefix it with token because it's a basic token. And then when I send that, I will be able to successfully create a project. So the main difference there is instead of using that little ID in the session cookie and seeing that go along with the request, we now have to include the token that is returned and generated by the backend through this endpoint. If we look in the code, if you haven't done this step yet, which I don't believe many of you have, the endpoint that we've added calls this custom auth token view. And whenever you complete a post request, which is what we've done here, API auth token, and we've done a post request, it goes to this token object and gets or creates a token. Now, token is imported from REST framework auth token models. Just going to zoom in slightly for you. I can click through on that and I can see the definition of that token class in the REST framework library. And down here, I can see exactly how they're generating that token. So there's a class method called generate token. What that does is it calls this class by an ASCII, which does some stuff. And then it does hexlify, which does a hexadecimal something. And then it gets a urandom integer of 20, and then it turns it into a string. So it's just a random generated thing, which is great. But then when that is generated, it's then saved to a token model. So that being said, if we come over to our database, you can see there's me, user number 3 with my username of username. There's another table here now called auth token. If I open that up, I can see there's a table here with tokens that correspond to user IDs. So token user ID 3, which is me. There's a token here, which is 9CDAC. If I view back Insomnia, that's the token I use to successfully authenticate or make requests. That means that, here we go. That means that Django is still going to a database to check whether or not the token I've sent is valid. So the token I've sent is just a random string that's been generated. And let's jump back to our diagram here. Even though we're not using a cookie anymore, it's still doing this. It's sending a request with a token now instead of a cookie, the server is still going to a table in the database. This time it's just the token table, and it's confirming whether or not that token exists and who that is for. It's then confirming that user exists, doing the rest of the work and returning data. So although we're using token authentication, which is different from session authentication, it's still a bit stateful. And the Django REST framework admits that it is a fairly simple implementation of token authentication. It even recommends like a third-party package that you should use to make it a bit more secure and a bit more, I guess, industry standard. So what we're really doing with token authentication in Django is allowing that request from different origins or different pages, but it's not something that we would recommend in productionized environments or websites. And because we're still hitting a database with every request, it's still also not great for high volume, high traffic sites. For the purposes of building out your portfolio projects and learning how these things work, it's fantastic and it's easy. But I think we want to look at something a bit less stateful in a production environment, because that's really where the industry is moving with the standard of authentication. So that brings me to a third type of authentication, which is also token authentication, but it's token authentication with something called JWTs. So in essence, JWTs, or JSON Web Tokens, which is what they stand for, are basically tokens which allow us to approach authentication, but in a stateful way. So these tokens are essentially JSON objects, so really similar to the data that it's returning from your REST APIs. JSON objects containing data about the user. And because these tokens contain data about the user, the backend server doesn't need to keep making requests to the database to check who the requester is, or that they are who they say they are. And these JSON Web Tokens, they're encrypted in such a way that the server can verify their validity without needing to track a session or make those additional database calls. So back to our club analogy, token auth is like showing up to a private clubhouse and showing your members card at the door. The bouncer looks at the card, and if it looks right, they let you in. They don't need to check a list because having the card is proof enough. So in this analogy, the card is the JWT token. If it looks right and it is verifiable, then your server can trust the data on that token, and it doesn't need to go check on the state of your user. The flow is similar, but with the key difference of not needing to check a data one extra time. Either registered or logged in, the user gets a JWT token back. This is then stored in the browser, not necessarily as a cookie, potentially in a different place called local storage or session storage, but it's still stored in the browser. Every subsequent request, you need to include that a session token is legit token in a certain fine. It then can continue to the rest of the database request it needs to make, or whatever it needs to do, respond to your request correctly. So I'd run through a quick example of what that looks like in practice. I have time to build out a full JWT using Django REST application. So I thought I would just show you on one that I know pretty well, which is that fantastic video editor I work on called Clipchamp. So you could do this on any public website you want, basically, and go in and inspect kind of like what kind of things are happening with the data you put in terms of your username and password, and what kind of requests are being made. You could then deduce what kind of authentication flows they're using. So if we log in with an email, I've just made a dummy account here. I'm just going to right click and inspect here so I can see the request being made. If I continue with the password, it'll log me in. And we're in. If we look at network, you can see a bunch of different requests are being made. The first one was to this endpoint email password. So this would be the endpoint that we would go to log in with an email and password. The response to this request, because I made this request with my username and password, the server then checked if a user existed. It did. And because it did, it then returned a token to me. And this token here, this big long string that looks really just keeps going. My client then storage. So we've got cookies down here, and we've got local storage up here. And this persists beyond browser. And then I refresh the page, or I go to a different page and I come back. I can still be logged in because I can still reuse this token as proof of the fact that I've authenticated with the site. JSON Web Tokens are a kind of a standard for encoding, meaning that you'll be able to go in and actually see what kind of data is being stored in the token and passed back to the client. So I can come over here and copy the token that was sent back for me, and I go to this website called jwt.io. This introduction page, it does give you a pretty good explanation on what they are, how to use them, the structure, and so on and so forth. We're just going to use this debugger here. Potentially, if my internet catches up. Beautiful. So you would just pop your token in there. And as you can see, up the top on the right here, we've got a header, which just goes into detail about the kind of token and the algorithm used. And then you've got the payload, which is the data that's being stored. We've got my email address. We've got a bunch of system-specific keys and IDs. We've got an expiry, which is actually a date timestamp. So this token expires on Saturday. Yeah, that's pretty much all my application needs to get going. And down the bottom, you've got something called a verify signature. And that is basically the part of the token that the server and the client can use to determine whether or not that JSON Web Token is valid. So the server will have a 256-bit secret that it uses in a function with the token that will check that they have been encoded and decoded in the same way. And that's that verification process. That means that we don't have to go back and forth to the database. And that's it pretty much. That's token authentication in a stateless way. That's token authentication in a stateful way. And that is session authentication in a stateful way. Does anyone have any questions? I know that's a lot. I'll take your silence as no. That made perfect sense, and I'm brilliant at my job. Cool. Well, unless there's any other questions, I thought perhaps we could go slightly deeper and just kind of dig into a bit more of authentication in a practical setting, as you would see in kind of day-to-day authentication uses. So I don't know about you, but I avoid trying to use a username and password when I log into applications because you have all those big security breaches, right? A lot of websites are having their databases compromised, and you hear about your credentials being exposed, and you have to think of 20, 30 different passwords. Otherwise, you're going to get doxxed. And it's something that did plague me a bit when I was in the Plus course, because I knew what I was doing when I was building authentication in the REST API, but I did want to know how could I allow my users to log in with like third-party sites like Microsoft or Google or Apple. And there's actually a whole there's whole frameworks out there that help you do this, which is fantastic. So basically, in the same way that Django REST framework has a system of rules and flows for you to follow to set up how an API works, there are actually organizations out there that one such is the OAuth 2 protocol, which if I can click my slide here, is basically the standardized protocol for authorization, which will providing specific authorization applications to remain compatible. OAuth 2 acts as a base for another protocol called OpenID Connect, or OIDC, and that's the acronym you see a lot whenever you go to set up authentication for a website through like a cloud provider or something like that. And basically, it's just a safe way for people to reuse existing accounts from existing identity providers to be able to log in without creating new registration usernames and passwords. So it's really bringing that authentication technology up to the expectation of users. For example, oops, if we went back to our favorite website, Clipchamp, which we can totally take the recording of this video from and go on and edit using fancy effects. And I try to log in with Microsoft. I come over here, I can log in with my Microsoft account here. And if I, let's see, I might be too late. Let me just try that again. I didn't have my DevTools open. We can see the requests that are made. So what's happening here when I log in with Microsoft is I'm redirected to login.live.com, which is Microsoft's authorization server. I choose the account I want to log in with, and then that would redirect me back to the website I want to go to, which is clipchamp.com. The request I've made to there would come back with a response with a bunch of different tokens. So what Microsoft have given me as I've logged in with their identity server is an access code, which is, or an access token, sorry, and that is an authentication token that I can use to make subsequent requests to Microsoft. And then they've also given me an ID token, and that looks familiar because it's a JWT. The reason you can tell it's a JWT is because it starts with EY. If I copy that JWT, I can then pop that into jwt.io, and I can see all the data that Microsoft have given back about me. That's information that my application can use. So once again, it's my email, it's the fake name I gave them. It's my age group, which is details about me that I have agreed in my Microsoft account can be public and shared with applications. You can adjust what kind of information can be shared with applications through your Microsoft account. You can give different permissions when you actually go in and select which account that you want. It's a whole protocol that makes it for a seamless experience. And as a developer, the ability to set these up are readily available to you through these protocols and through other third-party providers that follow these protocols and take the pain out of setting it up for you. But I just thought that'd be pretty interesting to know. It's like, yes, you're learning token authentication here in very, very basic terms, so you can get it done and you can make it easy, you can understand the concepts, but these base concepts are replicated again and again and again in pretty much every kind of authentication system that you touch, whether it be OIDC, whether it be biometric data, whether it be two-factor authentication. They're all using some form of state or statelessness, and they're all using some form of data to verify that you've been authenticated. So that is actually all I have. The takeaways I hope you have are the differences between stateful and stateful auth, statelessness auth, the different mechanisms used to provide proof of authentication in basic terms, a session ID or a token. If you are in the Plus course, you are implementing stateful token auth, and a really popular method that you'll find in most day-to-day applications on the web is the use of JWTs. Cool. I see I've got a hand up from Abby.
I just have a question about that tokens. You just showed us one that inspect the dev tools with the access tokens. So can some people get your access token from your web browsers and use for their own? Like consider like safety wise, is that secure?
In terms of if in terms of people intercepting access tokens, that is something that can happen. What makes the protocols around the flow that those tokens are used and the protocols within it are what makes the use of tokens secure. So it's the ability to encode and decode them and how they're used with who the user is. So you'll find with because we're sending these tokens in payloads of requests, they are harder to intercept than if they were used or sent in URLs of requests. So that minimizes the risk there. If someone does get a hold of a valid token of yours, they can use it to make requests on your behalf. So then you need to make sure that your tokens aren't valid for too long. That is the main defense against this. So as you can see on this one here, this one expires in 3,600 milliseconds. So how many is that? 3.6 seconds. In that 3.6 seconds between when we get that token back from the authentication server, the authorization server from Microsoft, to when we do something with it is within that time frame. So the amount of time it would take for someone to intercept that and use it before it expires is very low. So that's the kind of security protocols around using those. So that's why session authentication is so much more secure. But there are a lot of the OAuth 2 protocols and the OIDC protocols. They have specific rules laid out to follow in those authorization flows to avoid those situations.
Oh, thank you.
Yeah. Any other questions? If not, thank you so much for joining. My reward for you is my cat. Bye. So if you're in Perth, I'll see you Saturday. If you're in Brisbane, I'll be up in Brisbane in March to see Green Day. Otherwise, enjoy the rest of your Plus course. If you have any questions about what you're doing in the coming lessons around authentication, please don't hesitate to reach out to me. I'm so excited to see how all your projects and your the ones you're working on currently, as well as your final group projects come together. So I'll be sure to keep an eye out on your portfolios as they come through towards the end of this course. Great. All right. Have a good night, guys.